Hello guys, welcome to my YouTube channel. So today we will be solving Leetcode weekly contest 370 problem D, that is maximum balanced subsequence sum. Okay, pause the video, read the question, then we'll proceed. Cool. So in the question, what it is given is that we'll have one array, let's say a1, a2, a3, dot 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 a of n. Now from this array we have to make a subsequence. Subsequence is nothing but we can pick some elements following their order. We can skip some elements in the between. Okay. So we have to make a subsequence. So let's say I selected this a1, a3. So while making subsequence, we cannot select them randomly. We can only select the elements if they follow one particular condition, that whatever the first element we have. Okay, so or better to write that the index we are selecting. Let's say I am selecting the first index first. Okay, just a second, let me erase this. Okay, so let's say I am selecting the first index. Okay, that's fine, there is only one element, we can select that, nothing wrong with that. But let's say I am selecting the second element, right? So in this scenario, whenever I am writing or making a subsequent something like this, that means the value at this position, nums of 2, the index we are picking, and the index we have picked just before it, that is 1. So the difference of this value 1 should be greater than equal to the difference in their indices. Okay, so this is the condition mentioned in the question. So let's say next time I'm selecting the index 4 from this array, then that now our condition, according to our condition, this condition should satisfied, that nums of I minus nums of 2 should be greater than 4 minus 2. So generalizing this, what we can simply see over here. So let's say we selected indices I0, I1, something like this, Ik minus 1, k indices. So for each index that we have selected, what we can do is we can just simply write that the nums of I of j, the index we are selecting, right? And j is in the range, we have selected k indices, so j is in the range 1 to k minus 1, and this should follow that I nums of I minus nums of I0, I1 minus I nums of I0 should be I1 minus I0. So that's nothing but what the condition I have explained over here. Okay, so that's how we'll form the subsequence. And now what the question says is we have to return an integer denoting the maximum possible sum of elements in the balanced subsequence. Yeah, one more thing, that the subsequence will form following this condition will be called a balanced subsequence. Okay, so let's say there are many possibilities of making such subsequences. Then we have to return the maximum sum of elements, or the subsequence we have formed. So let's say what the question says is, let's say we have selected a valid subsequence of something like this, 2, 3, and let's say 7. These are the indices, right? Then we have to return the sum at these indices, that is nums of 1 plus nums of 2 plus nums of 3 and plus nums of 7, right? So let's say this was a valid subsequence A. There can be some valid subsequence something like this, let's say 4, 5, 9. Okay, then we will pick the sum of the elements at these indices as well, and out of all the subsequences, the maximum value what will be there, we'll have to return that. Okay, I hope the question will be clear now. So just to have a better observation or better understanding, let's consider this example, 3356. So example says 3356. Okay, now we know that the indices will be 0, 1, 2, 3. Okay, let's try to make subsequences over here. Let's say I take my first element as 0. There will be no issue, I can take first element, and it is mentioned in the question that taking one element will always be considered as balance. It was written somewhere. Okay, yeah, see, having length 1 will always be considered balance, so we can take 0. Now if we'll go on taking this 1, right, let's say I want to put this one, then according to our question it should follow the condition, that is nums of 1 minus nums of 0 should be greater than equal to 1 minus 0. Right side we have just 1, and here it is 3, and it also 3. 0 greater than equal to 1, no, this condition is false. That means we cannot put 1 after taking 0. Okay, so now let's check, can we put 2 after this? So if we sorry, the second element or the second index. So if we put the second index, then the condition will become what? 5 minus 3 should be greater than, or 5 minus 3 should be greater than equal to 2 minus 0, 2 greater than equal to 2. Yes, the condition satisfied. So if we'll pick 0 first, then we can put 2. Okay, now can we put 3 after this 2? 3 after this 2. So in that scenario, left side will become 5, sorry, 6 minus 5. 6 minus 5 should be greater than 3 minus 2. Yes, 1 greater than equal to 1. Yeah, the condition satisfies. So yes, we can put our index 3 as well. So this is one subsequence, one subsequence. Okay, so here if we'll make a subsequence 0 to 3, considering the indices 0 to 3, then at 0 we have value, at 0 we have value 3, at 2 we have value 5, and at 6 we have value at sorry, at index 3 we have value 6. So the total sum will become 5 plus 3 8 plus 6 14. So 14 is our one of the possible answer. We are not sure that it's a maximum. We'll go and see if there are any more possibilities. If yes, then yes, that will be our answer. Else, whatever the maximum value out of all the possibilities, we can return. So in this scenario, this 14 will be the maximum. We can see over here, the answer is 14. Okay, so now I hope question is clear. Now how can we proceed it? How can we proceed it? So the most important thing I would want to look you guys here is, so let's say we are considering two elements, ith element and jth element. Okay, so just to simplify, so let's say if I have this arrays, right? So let's say I have selected this ith element. This is the initial array given. So let's say I have first I have selected this ith element, and then I want to say, let's say this is the jth element. I wanted to select this jth element. Okay, so what we can say from here is that nums of j minus nums of I should be greater than equal to j minus I. That's what our question condition says. Like if we are selecting two indices, we have to follow this question. Okay, now now so if you'll observe carefully, and there's one very important point I would like to point out over here is, whenever you see something like this, that f of ith index, this is, let's say this is index I, plus something like f of index j, some condition not equal to blah blah blah, and it is equal to some, let's say index I, and multiply, anything can be here, or let's say multiply, not multiply, plus and j. If we find something like this, then what we'll try to do, we try to segregate all the i's in one side and all the f's into, sorry, all the j's in another side. So here taking this condition, what we can write it, nums of j nums of j minus, if we'll take this j from this side, it will become nums of j minus j should be greater than equal to nums of I. If we'll put this nums of I on the left right side, it will become nums of I minus it's I, nums of I minus I. So one thing you will note down over here is, we have the same thing. I mean, we just have to calculate for each of the scenario, each of the scenario, the same thing. If it's a jth index, then also we need to calculate nums of j minus j. If it's an ith index, then also we need to calculate nums of I minus I. Okay, now, so if we'll see here, our reduced condition has become something like that. Okay, let me write it a bit straight so that everyone would be able to see. Nums of j minus j should be greater than equal to nums of I minus I. Okay, this is our condition, reduced condition right now. Okay, so if our we have this array, so if we have this array, and initially we have selected this element, ith element. Okay, and this is the jth element, right? So this condition we can follow, so one thing what we can do, or the brute force way to, I mean, see, Right now, I know that if I want to add or take this jth index, right, I can only take it if some index I, or I can only place it after some index I which follow this condition. So let's say if we had this condition, right, this was the first example that we have solved, 3356. So if we'll take out or store this value nums of I minus j, that is the value at their index minus the index. So what will happen, the index here we have 0 1 2 3. So the value will become 3 because 3 minus 0, 3 minus 1, the value will become 2. And this value 5 minus 2 will become 3, and 6 minus 3 will become 3. Now we know that if we are at this zeroth index, then there is no element at behind. So simply we can say that the maximum value we can take till this index can only be subsequence made by taking this element, right, and the value will become 3. Now if we'll come at here, so for this position, now this will become our jth. Okay, this is our jth index. So we'll have to check if there is any nums of I, if there is any nums of I minus I which is less than equal to this value. So we will just see in its left side, do we have anything? No, here it is 3, and again it is 0. So if I will consider this element, then I'll have maximum sum 3. Okay, and also here this maximum sum 3 was this, not this 3. Okay, so now if we are at j is equals to 2, if I am at j is equals to 2, what I can do, I can check for I is equals to 0 and I equals to 1, because there are only two possibilities. So I'll check j equals to 0, sorry, I equals to 0, is that is less than equal to 3, yes. Then what I can do, this 5 can be appended at here, so our value will become 8. Now we'll check if this 5 can be appended after index 1. So at index 1 we have value 2, and that is again less than equal to 3. That means that also satisfy condition, our condition. So that means we can also take this element. But here we can see that this element and this element sum to 8. So eventually it will become 8, else we would have take the maximum of them. So if we are at index 3, then what will have, first of all we check. Now let's say if our j has become 3, j has become 3. So after j we have three possibilities, 0 1 2. Okay, so first of all we'll check, can we put this after index 0? Can we put this after index 0? Yes, because if we'll consider the index 0, there we have value 3, and this 3 is greater than equal to 3. Yes, then we can take the index 0 and we can have this index after 0. So in that scenario we'll have sum 9. Okay, now the same thing, can we take this here? Yes, then again the value will become 9. No change will be there. But if we'll select this second index, can we put this third index after the second index? We'll check. Yes, 3, and here we have 3. Now 3 is greater than equal to 3, our condition is satisfied. So that means we can put this element after this element. Okay, so we can put this element after this element, and we know that if we are at this element, 2th, we have maximum sum possible as 8. So our new sum become 40. And if we'll take this element 2 and put 6 after that, we know that we have maximum sum till this second index as 8. And if we'll select this 6 or the third index, we will add 6 to this value, and our value become 14. Initially it was 9, so 9 was less than this, so we'll update it to 14. So in this way, how what we are getting is, we are getting our maximum value 14 over here, and that was our answer. So I hope till here you have understood the problem. So if we'll see, what we are doing is, we are running a loop for I equals to 0, I less than n, I plus plus, or better, let me start with 0 j. So initially j was 0, j will be 1, and we are running a loop for I equals to 0, I less than j. That's what we are doing, right? If we want to follow this condition, we know that j can be anywhere previous, or like we cannot go further after j, right? We'll always check for the previous all the elements, because then only we are forming this condition. So we know that I can be from 0 to less than j I plus plus. Okay, we'll check if what this value, that is nums of j minus j. I mean, either way we can calculate, keep this value calculated, or we can calculate on it fly. So if nums of j minus j is greater than equal to nums of I minus I, then in that scenario we'll have one answer variable, or let's say dp of size n, dp of size n. And what we can write it, and initially this will all be initialized to, or it's better, let's start this as from 1th position, and we can simply put dp of 0 as nums of 0. Okay, so in that scenario what we can do, and rest all the things will be initialized to 0. Okay, so if this condition satisfy, then what we can write, dp of j, dp of j is equals to maximum of dp of j, mm, or whatever the value we have, this dp at I plus nums of j. Okay, nums of j. So and finally what we can do, we can simply return the maximum element of, sorry, we can finally return maximum of this dp. Okay, so I hope this would be clear till here. But one thing to, again if you'll see, here we are running nested loop, so it will again become of the order o of n square, o of n square, so if you'll see at the constraint, this is n will be like around 10 to the power 5. So this solution will give TLE, then why we discuss this, we have discussed this because from this solution only we will proceed to our exact solution, or the AC solution. So how we can do that, so let's say if instead of doing this much calculation, if somehow if we are somehow able to find our maximum element in, let's say, big O of on or big O of log n, then in that scenario our overall time complexity will become big O of n or n log n. Okay, and these two will be accepted. So all we have to do now is, how can we eliminate this second loop, so if we'll see what this second loop was doing, what, so it was doing nothing. So let's say if we are at this jth position, it was checking in this all these values, whatever the value we have of there, that is nums of I, minus I. First of all, it was checking for this, and if this is less than equal to nums of j, minus j, then we were taking out the maximum value, right? Because let's say if there were two values, uh, and let's say for I equal to 0 it also satisfied, and for I is equals to 3 it also satisfied. So if this here, the value will be like dp of 0, which will, let's say, something like 2, and for here it was dp of 3, which was something like, let's say, 10. Then and nums of j is 5, so our answer will be 15, not 7, right? Not 7. Why? Because we will place this j after this 3. So what we realize that first of all we'll find what is the max, like how many numbers, or what are the indices that will satisfy this condition, and out of all these indices we have to find the maximum value, or the maximum sum that is possible over here. So so if what we realize is that we'll have to store two things, right? First of all, what is the value of their position, or like whatever the value of this expression, that is nums of I minus I. And second is, what is the sum of all the elements if we have considered this element in the subsequent, sum of all the elements if this is in subsequence. I hope you understand it. So what we there are two things we need to store, and now we have to somehow reduce our search from O of n to log n, because I have implemented log n solution. I'm not sure if O of 1 is possible, but if we somehow reduce this to log n, then we are good. And okay, now how we can reduce it, or how we can get the intuition that we can which kind of solution. So if you'll see that for this jth, right, for this jth, let's say we are calculating two value, first one is x and second one is s. X is nothing, x was nothing, it was just nums of j minus j, and let's say s was, already we know that the maximum sum possible if we consider this element. So if I want to take this element, so out of all these element, what I'll have to do, I'll have to first find the values lesser than x. Okay, lesser than x, and then out of those we'll have to determine the maximum value. So let's forget the second part, let's go to the second part. I just wanted to know that how many values are there, or is there any value in whichever terms you would like to understand. So let's say how many values are there in this will have set. I'm just giving a hint over here that will have set, or how many values we can have beyond this j, like from 0 1 2 all the indices, how many values are there for which this condition, this x is greater than their x. Okay, this x is greater than their x. So let's say this is x of I and this is of x of j, and we know that this is nums of j minus j and this is nums of I minus I. So let's say if we want to find out, that how many i's are there for which this condition satisfied. So what can do while running a loop, let's say for I int equals to 0, I less than n, I plus plus. Okay, so what we can do, we can, let's say, calculate now x, and this will be key nums of I minus I. Then let's say if we had a set of int s, then we can simply do something like this, like auto it is equals to s dot. We want to know exactly how many elements are there which are lesser than this. So in that scenario, what we can do, we can simply use upper bound, and we can pass this value x. Okay okay so, or yep, so if we'll pass this, then what will happen, we'll have all the elements, or all the elements in this set which value is less than equals to x, and finally we'll also be inserting this x. So now it will make more sense. So let's say if I run a upper bound, so what it will do, it will give me the pointer of the element whose value is strictly greater than x, not equal to x. Okay, so what we can say, that all the elements beyond that pointer will have value lesser than equal to x. So even if, let's say, we have indices 0 1 2 3 4, and here we had value 1, and here 7, here it was 4, here it was 2, and here it was 3. So now as we are putting this values, this value is nothing but this value nums of I minus I. Okay, so as we are inserting this in set, so the moment we are at 0, it will become 1. We are at 1, it will become 1 and 7. If we are at 4, the moment we'll insert it, it will get sorted something like this, 1 4 7. Okay, similarly, if we will insert 2, then it will update to 1 2 4 7. So for 3, when we'll search, it will give us pointer to, if the here, when we search for upper bound, it will give us the pointer for this 4. Okay, so if we'll see over here, our first part is resolved, because we know that from here we know that we have to find all the elements. Whose value was, sorry, where we were discussing that. Just a second. So here we are discussing, right, that in all the elements we'll have to first find how many elements satisfy this first condition, and of all those elements who are satisfying this condition, we have to find the elements with maximum sum of that subsequence. Okay, so the first thing we know, that we can use this upper bound. Now only thing we need to know is how can we find the maximum sum out of all these elements, like we are not sure, right? So here comes into the picture a very little optimization, nothing much. So instead of storing just x, what we'll do, we'll store x and the sum, the maximum sum we can make if we have used that particular element. Okay, so now what will happen? Let's see what will happen. So let's say if our x is 2 and sum is 10, no issues. If this is our main set, okay, this is our set. So the element will be like something like this 2 and 10. And let's say there is one element 3 and 14, no issues. That will also be there 3 and 14. Okay, but let's say there was one term which was something like this 1 and 50. So ideally this will be sitting over here 1 and 50. Okay, okay. So this is 1 and 50 over here. This is 1 and 50. Okay. Now let's say for any particular index j, our x is, let's say, 4. Okay. If our x is 4. So in this scenario, what we'll have to check? What we'll have to check is if this, or in this element, do we have anything, do we have anything or any element whose value is greater than, less than equal to this x. Okay, so that how can we find it? We can simply, if we found an upper bound on, I am just keeping this value blank. So if we'll just have upper bound something like this, upper bound, then what it will do, it will find all the elements, which are lesser than this value x, first value, and will give a pointer to that. But now, if, even if, let's say I put here int max or anything, okay, we'll discuss this later, what value we should put over here. So in this scenario, what it will do, it will give the upper bound over here. Okay, upper bound over here, or for better understanding, let's say if it's 5, then it will give upper bound over here, because we are x have 4 and this 5 was strictly greater than 4. So now that means we can choose all this element, and we can choose all this element. But but if we'll just look back, then this is 2 and have value 10. So our most optimal choice would be going with this one instead of this 10. And also if we'll see over here, if our one element is 1 and 50 and another element is 2 and 10. Okay, another element is 2 and 10. So what does this signify? This signify that if we are just ending at, this first value, okay, and if we are going at this second value, then this will be the value and this can be the value at the first value. Now let's say if there is any nums of I, what I am trying to say, let's say nums of j minus, if we consider it is the first position, then the value will become nums of 1, okay, greater than equal to j minus 1. And if we consider it as for the second position, then the value will become nums of j minus nums of 2, or it's better to write directly in the form we already know by keeping the j one side. So it will become nothing but nums of j minus j is greater than equal to nums of 1 minus I, and nums of 2 minus 2. This will be the second value, right? And we know that if these value are equal, if these values are equal, or if any value, whichever value is smaller, if we can take that, or if the, sorry, I'm confusing over here. So what I'm trying to say is, if we have 2 and 10, okay, and if we have 2 and 50, so next time for any j, if we have 3 and something, we have to determine this value. So if we have this 3, that means we can also take this 2 and also take this one. Yeah, right, because we know that we can take any values beyond this j whose this x is less than equal to. So do you think, does it make sense to consider this element if we have some element whose this x value is lesser than this, and this sum is greater than this, or the sum value is greater than the second sum value? Okay, so listen carefully, what I'm trying to say is, if I have 1 and 50, what does this mean? what does this mean? That we will have one subsequence, where the last element, whichever we have considered, will give our value, or this right hand side value, as 1, and the maximum sum we can obtain is 50. Whereas the 2 and 50, sorry, 2 and 10, what it does signify? That the last element we have selected, that nums of I minus I is equals to 2, and the maximum value we can obtain is 10. So whenever we will select any x, we know that this value, this can only pick the elements whose value is lesser than x. And if x is greater than equal to 2, that means x will definitely be greater than equal to 1. So if we have such kind of element, if we have this kind of element, that means we can simply remove them, because it's always better, it's always better to take this value. Because why? Because this, the maximum sum that can be possible here, is greater than this. So instead of, what we will do, so whenever we will be inserting, first of all, what we will do, we'll insert two things, x and the maximum sum possible. Okay, now how this maximum sum will be calculated? So first of all, we will do upper bound on what? Upper bound on x, and this will be the int max. Okay, I mean, if we'll keep on deleting, that doesn't mean if we put any value over here, we'll have our answer. But let's say we are taking int max. Okay, so what will happen? And yeah, the moment, or the before we inserting, the moment we have calculated this, we'll start deleting. So start deleting elements. So what I'm trying to say is, let's say if we have 150, okay, and 370, okay, and if I want to insert 280, right, if I want to insert 280, then I can safely delete this 370, right? So what I will do with the moment I will insert this 280, I'll delete this 370. Okay, I'll delete this 370. Okay, and let's say there was some element like 490 or something like this, then it's okay. Okay, so our new, the set we have will become something like set of vector int. Okay, and we will store always x and s. Okay, and now we have made sure that this x will always be unique. Because we will always be deleting the elements where this x is greater than equal to, or like x1 is greater than equal to x2, and this s1 is greater than equal to s2, then we will delete this x1. And the only condition, like when we need to take care of this deletion, whenever we'll be inserting our new element. Okay, so like coming to the solution, it will be much more clear. So I have broke the solution into two part, but even if you want, we can have this solution in one go. But initially at the time of contest, I have broken down into two part. So let's say if we are inserting, first of all, we have run a loop, or we inserted this, the first value, we calculated the mx value. Why I am keeping the mx value? So if this was the set, the last value, or the maximum value anywhere, the maximum value, so out of all these bounds, the maximum value I can have, or the maximum sum I can make, is stored in this mx variable. Why? Because let's say if the last element was something like this 10 and some values, okay, and I have now x as 12, then this 12 is greater than all the elements. So whatever the maximum value I has in this can be taken with this 12 value that I have done into contest. But we can remove that as well if you want. Okay, first I will just explain this solution, then we'll remove that. Okay, so what we did, we just first of all we checked, or we inserted the zeroth element, stored its value into mx, which started with 1th element, and we calculated x. We calculated the end variable. Okay, we calculated the end boundary, and we checked if that end element, okay, if that end element is l- lesser than this current x, then we can simply add the maximum, or x value, sorry, mx value, okay, to our current element, and we can insert it back. But also we'll check, let's say initially it was something like -10, and now I have -1. So it's always better to take -1 alone than taking with -10. So we'll check whatever the maximum we have, either the current element or the sum with the previous elements. Okay, that we will insert. And we also what we'll do, we will just find and delete everything. We'll find and delete, but here deletion is not necessary. I am refactoring my code, and this is very important point to note down, guys. I have solved this question in the contest, but now when I am explaining you guys, I am finding new ways and better ways to solve it. Okay, so what will happen, we can simply delete this, no need to worry about that. And else let's say if this was not the case, then as discussed in the solution, we'll found the upper bound. We will check if the value, or like, let's say in if any scenario, if in any scenario our element is started with something like this, like 10 and something, and currently we have 5 and something. So in this scenario we can't take any elements. So if we calculated the upper bound, we'll check if we can go back, then yes, we'll take the maximum sum if we can make any before that point, and then we will add it to our current element, and again we will have our same validation if taking those elements will make more sense, or taking this current element is better, and then we can insert it. And once insertion, let's say if there was something like this 1 and 10 already in there, and now I am inserting 1 and 14, then I will delete this. So whatever the value I have found right now, this it. Okay, so I'll first calculate this value, insert this value, I'll find this values, and whatever the value we have, we'll simply delete that. If we have something like this, no, not this 110, this won't be get deleted. Let's say there were 210 or 212, something like this. So as we are inserting 114, so the values like 210 or any greater value, let's say 2 313, some anything, or 311, so those value needs to be deleted. So those values I am deleting over here. Okay, and same, we are maintaining the mx variable, and we are finally returning the mx. Let me try to submit it, and you'll see. Just the second, guys, it seems a bit issue. Yeah, it got accepted. Okay, so I hope you have got the solution. But yeah, there is one more optimization which I just thought while explaining you guys, that we don't need to make the separate calls. We can simply have all this in one go. We can simply have this all this in one go. Okay, so what will happen now? First of all, we'll insert this 0th element. Okay, we also don't need mx, but let it be there. Then we'll calculate whatever the x value we have, then we'll find out the upper bound for it, then we'll calculate the maximum value, and then we'll proceed as discussed. Okay, just a second, guys. Unidentifier it. Okay, here it will become auto it. Okay. Okay, wrong answer. Okay, I'll have to see into this, but I don't want to stretch the video. So I hope you have got this. So here we know that we have an easy solution. So let's, for the timing, better go with this. I'll paste the other solution in the link. Sorry, in the description. Okay, if you guys have any doubt on this, do let me know in the comment section. Okay, thank you guys. See you in the next video.